Hi, and welcome to At Home Science, where we show you some cool science stuff to do every weekday. Today's topic is the one everyone is thinking about, viruses. Viruses are kind of like small bundles of genetic stuff that can get into our cells and hijack them to make more and more copies of themselves. Today, we're talking about the coronavirus, which looks a lot like this. There are a lot of other different shapes and sizes of viruses, but this is the most important one for us right now. The coronavirus is surrounded by a kind of shell that's made up of stuff that looks like this. If you were to take a chunk and look at it from the side, you would see that that shell is made up of millions and millions of tiny little chemicals that look like this. They're called phospholipids. The head of them wants to go towards water, so it's called hydrophilic. The tail of them gets pushed away from water. That makes it called hydrophobic. If you have a whole lot of these phospholipids sitting around, they stick together to make a long layer that surrounds the entire virus, protecting it from the outside. So to get rid of that protective coating on the outside of the virus, we have to do something. Here, I'll show you. What I've done is I've poured some water into a dish. You're going to want to do this at home too. Make sure you get one that's white in color so that the things show up better. We're also going to need some pepper. And you're going to sprinkle the pepper on top of that water. It's going to spread out and float. Now, the pepper represents the outside of the virus. If you add soap, soap can change the properties of the water it goes into. Let me show you. Take a tiny drop of soap and dip it in there. Look what happens to the virus outside. It gets pushed away. Soap can change the properties of things it goes into. In this case, change the surface tension. For viruses, it does something even more drastic. Here, let me show you. So if we have a virus like our model right here, and you just add water to it, nothing really happens. The outside fatty layer, that fat shell, protects the virus, so nothing happens. But watch what happens if we try the same thing right over here, but we're going to use a little bit of soap. Adding the soap to the water, and we pour it over our virus, we're going to see that a little bit of soap can make all the difference. And we're going to see that this virus is not going to last very long when it's surrounded by a whole lot of water and soap. And the parts of the virus that are touching the soapy water are melted away. So the soap has attacked the virus wherever it touches when torn away that outside protective coating. That means the virus can't survive, and so you're safe. So that's why it's so important to wash your hands with soap and water. You want to do it for at least 20 to 30 seconds. Now we're going to talk about how this virus can be transmitted. One of the ways it can spread is by coughing. Whenever you cough, you don't just give off air, you also give off tiny little droplets of spit. Gross. Kind of like this. The virus can hitch a ride on those tiny little droplets and go through the air for short distances. Here, let me show you. Actually, follow along with me and we'll make something you can try it out with at home. What we're going to make is some bubble solution, because I don't know about you, but I often forget to have it in my house. So here's what we got to do. You're going to need about 250 milliliters of water. You're also going to need some dish soap. And last but not least, you're going to need some glycerine, which your parents might have, but might not, or some corn syrup. Here's what we're going to do. Take 250 milliliters of water and pour it into a container. If you don't have an Erlenmeyer flask, that's okay. Next, you're going to measure out 250 milliliters of dish soap. And you're going to pour that 250 milliliters into the exact same container and give it a chance to sort of mix up. Just like this. Last but not least, you're going to want to add a very small amount of glycerine. So if you're using glycerine, you're going to want to use about 5 to 10 milliliters. That's going to be, I'm going to pour just a little bit to the very bottom. Pour that in there. If you're using corn syrup, you're going to want to use about twice that much. Now for our demonstration, what we're going to do is add a bit of food coloring to the mixture. For this demonstration, the food coloring represents the virus. So we'll add a bit in there, and we'll give it a swirl so we can change up our color, just like this. All right, here we go. To make a bubble wand, you're going to want to use a pipe cleaner. Make it into a small little shape, just like that, and lower it into your bubble solution. The bubbles represent a droplet, like the kind you can cough or sneeze out. When they go through the air and land and pop, you notice they've left behind some food coloring, which represents our virus. So this is one way that viruses can travel short distances through the air. So that's today's at-home science, and we'll be seeing you soon.